Okay, so we continue our lesson into functions. Okay, and for the previous lesson, we talked about what is a function and how do we determine that something is a function or not. Okay, and in today's lesson, we're going to look at the different characteristics of a function and what all the inputs and outputs of a function can possibly be. So just to recap a little bit. Again, the definition of a function is a rule or machine with inputs and outputs, and the key is that every input has exactly one output. Okay? And so to look at, again, I have our two non-math functions. You have a toaster with input and output. Inputs bread, outputs toast. Okay? You have a washing machine that inputs dirty clothes and outputs clean clothes. Now, the thing about functions is that you can't put every input into there because some inputs are actually going to break the function. So let's say you have your washing machine here and you input bread. That's going to break your function or break your washing machine. Same thing with the toaster. You can't try to toast your shirt. If you input a shirt into the machine, it's going to break. Okay? So what does that mean in terms of mathematics? What inputs can possibly break a mathematical function? Well, let's look at what we have here. F of x equals 1 over x minus 3, and this in fact is a function. Okay? But watch what happens if I were to input 3 into the function. Okay? So I've written it down here so we can all see it. Instead of writing x, I input the 3 here, okay, and I have 1 over 3 minus 3, and that's going to lead to a problem because I have 1 over 0. Okay? And there can't be any output here because you can't divide by 0. Division by 0 is undefined. So in this case, an input of 3 will break the function. Let's look at one more example with mathematics. This time I have square root of quantity x minus 3. And let's say I were to input 1 into the function. Well, here you have 1 minus 3, and the whole thing is inside a square root, so that gives me square root of negative 2. Okay. And again, there can't be any output because it gives you a non-real answer. Okay. So you cannot have any imaginary answers to a function. In that case, it would be an invalid input. So here we have a definition of domain and range, and first, domain is all possible valid inputs, and the key word here is valid. Okay, we can input a lot of things into a function, but it's only part of the domain if it's a valid input, and by valid we mean that it will not break the function. And the range is all possible valid outputs. So to look at an example with our two quote-unquote machines, the domain of a toaster would be all different types of slices of bread that can fit in the toaster, and all of the different and the range of the toaster function would be all possible toast that could come out of there. Now, returning to mathematics here, there's just a few rules to determine domain. There's actually many rules, but for right now we're just going to learn 3. Okay. First is that we start with all real numbers. Okay? And so it's nice to start with all possibilities and see what we can trim out of there. Okay? And then we eliminate any inputs that lead to division by 0. And next, you eliminate any inputs that lead to non-real answers. And that's really it. These two rules here are it. Okay, well, there's kind of a third rule that we start with all real numbers, but after that you use these two rules that there can't be division by 0 and you can't have non-real answers like the square root of a negative number. Later on we'll learn some other scenarios where inputs can break a function, but for right now we just have to keep in mind these two concepts. No division by 0. You cannot have a non-real answer. And so in the next lesson, I'll be able to explain to you just how do you find exactly what a domain is for a specific function.